part 1. So this is the third video in our video series, but now we're going to be specifically factorising quadratics. So first I want to talk about a question we did in the past lesson on expanding binomials. Well, a type of question. We're going to expand a binomial that looks a bit like this: x plus p times by x plus q. Now ultimately in this video, we're going to be working towards that factorized term. But I want to expand this first. If I expand this, I get x times x plus q plus p times x plus q. And this is equal to x squared plus qx plus px plus pq. And this is x squared. I've got a common factor of x here with a q plus p remaining, and then I've got pq. Now let's compare this to our standard form, and our standard form was ax squared plus bx plus c. Now I really want to highlight a couple of things here. First of all, this last term, pq, these two terms inside the factorization, multiply to give c. That's going to be a really important fact. And also, you'll notice in this linear term that b, the coefficient of x, is equal to q plus p. That comes out naturally in our expansion here. So again, the two numbers inside the factorized form must add to give b. Lastly though, and this is quite important, you'll notice that a is equal to 1. So these are for cases where a is 1. In a future video, we'll talk about the cases where a is not 1. For today, we're just worried about where a is 1. And if a is 1, this is called a monic quadratic. Sometimes a unitary quadratic. It just means that there's a single x squared. It's not 3x squared or 10x squared or anything like that. So today we're dealing with when a is 1, when we have a leading term of just x squared. So let me show you how this can help us by using the fact that b is equal to q plus p, and that c is equal to pq, p times q. And let's have a look at an example. Example number 1. X squared plus 5x plus 6. So in this case, b is equal to 5 and c is equal to 6. So our two numbers, p plus q, must equal 5 and pq must equal 6 for this to work. Now before you get excited and realize that we have a couple of simultaneous equations there, it's usually a bit easier than that. We can set up some nice little rules to help us. So in this case, I'm hoping that maybe you've already realized that p is equal to 2 and q is equal to 3. And so this factorizes down to be x plus 2, x plus 3. And if you want to check my answer, you can go forward there and re-expand that using the distributive law, and you'll find that that's true. So let me set up the form, how we can go through this in a consistent routine way. You may set things out different to me, but ultimately it's nice to have some distinct layout that makes it easy and clear to understand. So I always recognize that we need two numbers that add to be 11 and that multiply to be 18. So I've just got the 11 as the coefficient of x and the 18 is the constant term. Now I just need to go through and think about those two numbers. Now there's a few ways you can go about this. First of all, and this is hard for me to write down, so I'll probably just explain myself on a few occasions. First of all, these two numbers are both positive. The only way to multiply two numbers to get a positive would be if these are both positive or these are both negative. But if they're both negative, they won't add to positive 11. So I know that my two answers are both positive. There's hints there. Now they also add to give 18. So I know that they must be a multiple pair of 18. So 18 and 1, for example, or 9 and 2, or 6 and 3. And I look at this set, I think which ones add to give 11? They have to add to give this term. And I can see that 9 plus 2 is 11. So my new two numbers are 9 and 2. 9 and 2. You practice a few of these, you'll start to get really good at that. And so this is equal to x plus 9, x plus 2. Now let's see what happens when we start to vary the negatives. X squared minus 4x minus 12. So we'll do a double negative here. So in this case I need two numbers that add to give negative 4 and multiply to equal negative 12. So first of all I'm going to look at that multiply term. If they multiply to give negative 12, it tells me for sure that one of them is negative and one of them is positive. But there's still a factor pair of 12. So 12 is 12 and 1, 6 and 2, or 4 and 3. Not only that, but the difference between them, because one's negative and one's positive, when I add them together I get negative 4. So the difference between them is 4. Which of these two, where one is negative and one is positive, will add to give a version of 4? And I can see in this case that it's 6 and 2. 6 minus 2 is equal to 4. So it's not that. It's actually 2 minus 6 is equal to negative 4. And I can see that 2 and negative 6 are my answers. So I get x minus 2, x plus 2 and x minus 6. And there's my factorization. So it's just building that logical understanding. I'll give you two more examples. Example 4. X squared minus 7x plus 12. So in this case I need two numbers that add to give negative 7 but multiply to give 12. So because they multiply to give a positive, I know that they're either both positive or both negative. In this case though, negative 7 is a negative, so both the numbers must be negative and they must add to give 7. So I have 12, which has factor pairs 12 and 1, 6 and 2, 4 and 3. Which of those add to give 7? 4 and 3. And so it must be negative 4 and negative 3. Negative 4 and negative 3. As those add to give negative 7 but multiply to give a positive 12. And so this is equal to x minus 4, x minus 3. If you're wondering, it doesn't actually matter which order we put those brackets around either. And example 5. X squared plus 7x minus 30. So you'll see here this is the other variation, the last variation we haven't covered. Two numbers add to give 7, multiply to give negative 30. So those two numbers, because of the negative 30, I know that one of them is negative and one of them is positive. So again, I'll write this down. I'm going to keep all my hints together. Not only that, because they add to give 7, I know that the difference between them is 7 and the positive number is the larger number. So if we were going to avoid the factor pairs of 30, and there's quite a few factor pairs of 30, we could start looking at numbers like, what two numbers are going to add to give 7? Negative 2 and 9, for example, works, but that only multiplies to give negative 18. What about negative 3 and 10? That works, and it also multiplies to give negative 30. So I've got my answer there just by observing that 7 instead of the negative 30. So you can do the factor pair thing, or you can look at the addition term, the 7, the b value as well. And so this therefore splits up to be x minus 3, x plus 10. So there you have it, some factorising, and as you can see, it's really not that bad. You just have to be very procedural with it and make sure that you understand the logic behind what happens when terms are negative and positive, etc.